Good morrow, fellow humans. My name is Sean and I am obsessed with infinity. And welcome to our second Unfoldings session. Unfoldings is a sub-series that I put together that enables us to have a bit more of a nuanced look at some of the more technical, philosophical or scientific ideas that pop up in the usual Infinite Now series. But it also gives me a chance to answer some of your questions. And I will use some of your questions to unfold the topic that we're going to talk about today, which is space and time, but also the unavoidability of the observer. So let's get into it. In the very first introductory episode, when we got to the end of that episode, we asked whether it would be more appropriate to ask the question why or how in order to best unfold this metaphysical journey that we're on. Which of those two questions is best to enable a more accurate understanding of reality? The answer that we have given ourselves for now was that why required a certain entwining with our concept of meaning. And meaning is always entwined with the observer, whether that's the individual or whether it's a godly meaning that's imposed upon the system as a whole. But it always required meaning, which meaning in itself is either, at worst, something that is other than the universe. It's something separate, like some metaphysical frameworks consider it to be something separate from what the universe is, consciousness, mind, or matter. Or at best, it's only a finite segment. It's an attribute of nature, or it's an attribute of reality. So considering that, we propose that anything that is entwined with meaning won't be able to give us a totalistic understanding of what reality is, and for that reason, we've temporarily put it aside. That then leaves us the question how. And of course, the question how is the fundamental basis of what science is, so we are unfolding our narrative along those more materialistic lines, trying to understand the world as it exists through the eyes of science. That led us on to space and time. As we started to unpick these topics, firstly we started with how large is the universe? Firstly, the observable universe, but then how large can the universe be? We then spoke about the Planck length and how short measurable space is. And obviously, we understood the observable universe to be 90 billion light years in diameter. Now, a question popped up in the comments from Phony McPhoneson, who is a regular commenter, so hello to you. Phony asked, why is it that the universe, if it's around 14 billion years old, and nothing can expand or move faster than the speed of light, well, 14 in every direction from us on either side, that would add up to 28 billion light years of expansion. So why is the universe this 90 billion light year diameter and not what we would propose as the 28? And that is a very clever and intuitive question to ask. And it is a question that I've asked myself. And it comes down to what space is. Now, the metaphor that usually gets offered is that of the raisin loaf in the oven as it slowly expands. If you consider ourselves to be one of those raisins, we see that all of the other raisins, as that loaf expands, are moving further away from us. However, the ones that are further away move faster than the ones that are closer. So there is an expansion of space that is accumulative. And that accumulation of space is what leads those further distances to appear to be moving away faster. Now, that's only the first part. The second part has to do with what space is as far as our understanding of it, because when we're talking about space, we're more often talking about the fundamental constants of nature. The fundamental constants of nature, it's debated as to how many there are, but the few that are usually taught are the speed of light, the gravitational constant, the elementary charge, and Planck's constant. Planck's constant gives us the scale for quanta and that sort of thing. Now, they're considered to be non-observer dependent. doesn't matter who you are, where you are in the universe, when you are, whether you're close to a dense gravitational source, whether you're traveling fast. These constants are supposed to be exactly that, constant. They don't change. So to say that space is expanding, we might think that we're saying that space itself is stretching. And when you look at a lot of the diagrams, that would be the impression that you would be left with. That's not exactly true, because if it was stretching, what we're essentially saying is that the relationships between the constants, they are the things that are stretching. And if they're non-observer dependent, if they're always the same, then they can't be stretching. Those relationships need to be consistent wherever we are. And so therefore, the expansion of space that we're talking about is not a stretching of space. That's one. It's also not a fact that the entities that are further away are flying away from us and that there's a vacuum between us, that there is nothing between us, that they are moving of their own accord away from us, because that would suggest that they're moving faster than the speed of light. So that's not the case either. What the answer is that is given to us, it's not very intuitive, but it suggests that there is more space being accrued within the vacuous regions of the universe. Those dense regions, such as the one that we're currently in right now, they stay fairly static. They don't really change. But within the vacuous areas, we have more space being accrued. And then in that sense, it's much more like the loaf of bread in the oven. And we see things that are traveling away from us faster than the speed of light. They're not moving away from us at faster than the speed of light. There is no faster than light movement taking place. That transition is only accumulative as a result of the expansion of space itself, as the accumulation of space. Now, there is a question that does pop up very quickly there, which is, where is all this new space coming from? And it is not properly understood. There is some very complex thinking behind it, and it's something that we will have to get into in another episode, but that is planned and we will get to that later on. So thank you, Phony, for that question. But that is why the observable universe is 90 billion light years rather than 48. We then got on to the concept of time and how it can warp and change now with Einstein's relativity. The faster that you move, or the closer you are to a dense gravitational source, the slower that time moves, or the slower that your clock moves. And your space also contracts. It compresses, and if you are traveling as fast as light is, if you're traveling at the speed of light, it compresses so much that space itself is meaningless. Time doesn't mean anything. And there was a question about this. This question was from @m.l.4007. Hello, M. Thank you for joining us. It says, so a photon traveling from a star far away hits my eye and then leaves the star at the same time or in no time. That's the question. The answer is both, because the space itself has contracted. There is no space for it to pass, and therefore there is no time. One of our other commenters actually got into this topic themselves before this question was posed, and I'll read their answer for you. This is @websurfer352 who wrote this. @websurfer said in response to the questions that I posed in the episode, if it took zero time to traverse a space, that would mean instantaneous speed to traverse that space. And that negates the distance or length of that space. If there is no space to traverse, then it's instant, so there is no time, there is no space. That is what it is from the perspective of a photon. However, because that doesn't make sense, he then goes on to say what many physicists say, which is, that is why light, from its own perspective, does not experience time nor distance. Light is not really in the universe as seen from its own proper perspective. Light is not really in the universe as seen from its own proper perspective. Now, does that make more or less sense than the statement that time does not exist for a photon? That space, dimensional space, doesn't exist for a photon. Neither of those answers really make sense. Both of them are completely counterintuitive. They don't have any rational place in our mind. However, that's what the mathematics tell us. And this is a point that needs to be highlighted, because when we talk about time, when we talk about space, especially when we talk about it in terms of things like those constants of nature that are non-changing. Non-changing from what perspective? From the perspective of the observer. Light doesn't have a perspective. From whose perspective does it not have a perspective? From our perspective. From a perspective of a matter-bound creature that is in space and time, that cannot ever reach the speed of light. So this idea of saying that the universe, does not have capable to it the perspective held from the at rest frame of a photon, is similar to saying, consider yourself to be the photon. You have your world, you have your friends, you have your families, you have people passing you in the street, you have pets, animals, there's insects in your house, there's all these different things and entities that have a perspective of you. What we're saying is those perspectives are what you are, and that the perspective from the center outward, assuming you're a photon, that perspective doesn't exist in reality. I'm not saying that it has anything to do with a conscious perspective. I'm saying that perspective does not exist within reality. That's what the mathematics is telling us. Now, the problem is when we take these mathematical ideas, we translate those ideas into words, we understand what the words mean, but when we put them into the sentence that tells us what it's trying to tell us, we can say it, we can repeat it even, we can believe it, but we don't truly understand it. And it's because of this that in the start of the 20th century, this idea of time that was taking hold, this very materialist idea, was debated by philosophers. And one of those philosophers held a belief that there is only a present moment. Now, I put up a poll just recently for all of yourselves, asking you which mode of time you thought best described the nature of temporal reality. At 44%, the winning answer was presentism, that there is only this one moment. That the past and the future are abstractions of mind, abstractions of human creativity, and it's only the now that exists. Now, that now is multifaceted, that now is complex, that now is not a single instant in time. And when Henri Bergson argued this point with Albert Einstein and the physicists of the early 20th century, he spoke of a present moment that gnaws into the future, that has a shape of duration, and that this duration is fueled, once again, by memory and anticipation, by the perspective holder of the individual. So instead of trying to attack this world and take out the observer, which is what much of science was for its first 300 years of development, trying to do things at an arm's length, the philosophers of phenomenology, which basically followed Henri Bergson after this point, intentionally put the observer back in the seat from where we are taking our measurement, from where we are trying to understand reality. We can't take the observer out. We can't take this entity that's trying to understand itself out of the picture because it is part of the whole. And that's the understanding that we came to at the end of our most recent investigation. And that is why in future episodes, we're now going to start trying to unpick the idea of what this self is. We will do this, however, continuing in the materialist vein, in the physicalist vein, trying to understand the biological self and then the quantum mechanical self. And we will continue to prod this philosophical doctrine, this metaphysical view, until it reveals its boundaries, until it tells us that it can't tell us anything more. But this type of thinking does kind of get us to start playing with these ideas in a different way, especially if we are familiar with the science and inspired by the science and take the science and repeat it to others like I have in the episodes thus far. How much of those answers that we give to these questions really offers us any proper understanding of what reality is? Partial understanding, most definitely, but ultimate understanding, I'll leave that up to you. That's where I'm going to leave you today. Thank you so much for tuning in. I do hope that these unfolding sessions are useful, and I would very much appreciate a bit of feedback in the comments, letting me know if you would like me to continue these or if they are just not what you came here for. If you came here for the pretty pictures and the slow, meditative, deep thoughts, that's fine. Each to our own. Thank you very much. Much love, and I hope you all have a wonderful, wonderful week. All right.